Hello everyone, welcome to this session on switching theory and logic design. Myself Dr. Sohail Rana, and I am going to deal with this subject for the second year students. So I hope all of you will enjoy the journey in this course, and as in our introductory video we have discussed the parameters which are very interesting and important with respect to electronics and communication engineering. We should proceed along with that. So let us begin with our today's discussion. Today in our session we will have introduction to digital and analog systems. So in that context, first I would like to give some benefits. What are the benefits of these systems, so that we can get more interest in the subject. So very first thing what we have to understand is that first we should find out the reason. What is the reason to study this subject? So let us explore few reasons or few advantages, we can say, of this system which we have to study, and then we can get more interest while studying this subject. So first thing, we have two types of systems. In nature we have two types of systems. Natural signals, those are called as analog signals. So natural signals are analog, and for our flexibility, our facility, our benefit, we make digital systems. So both of them are important. Analog, as it is a natural signal, it is also very important, and digital, of course, nowadays we are living in digital era, so this digital system is also very important. Nowadays which gadgets we are using? For example, the most loved example gadget is mobile phone. In mobile phone is a digital device. Sorry. Now let us consider few examples where we can have a difference between analog and digital systems. Say we can have two types of watches. Say one type of watch is analog. So at an analog watch, what do we have? We have one minute needle and one hour needle, and there will be one second needle, and it will be rotating with mechanical movement. And digital system, what we will have? We will have a digital clock. Suppose now the time is 4 o'clock. So here we have smaller one, hour needle on 4, minute one on 12, right? And this will be something we can see on the analog watch. On digital watch we can see some linings like this. The digital display, say 4, 0, 0, 0, right? So if we observe one drawback of analog watch, so we can explain it in a way like from front view, if someone watch, exact 4 o'clock can be visible. But if someone watch from extreme left side, so he can see small deviation in the time. He may feel that now 3:59 is the time. Or if someone watch from another corner towards this analog, he may feel that okay, now time is say 4 o'clock and 1 minute past. So there may be some human eye error if we talk about analog system. But if we talk about the digital system, if you see from front view or some other angle or any other corner, you can see exact 4 o'clock, because these are digital numbers. So this is one example. Another example, you might have seen the tape recorder cassettes. Tape recorder cassettes. They are like old tape recorder cassettes are example of analog system. Let us see them. We can have some images on net if you explore. See, earlier these kind of record cassettes were there. This was analog. So on this reel, if you might have played with this reel, so what was there in these reels? It was the song was embedded in that. So two sides were used to play on this cassette, and maximum of 14 to 15 songs were playing. Okay, and that was the system. Now this size of this analog tape was in meters, very long, and there was requirement of one tape recorder or cassette player to play these cassettes. So on this very big size, there were only maximum 14 or 15 songs. But nowadays, if you use your memory card, store in your 120. Now these are the few examples we have seen. But now let us list out some advantages, or what we are saying reasons to study this subject. So say one by one we can discuss. First thing, they are very easy to design. Digital systems are easy to design. So designing part is easy, that's why we prefer them. Like here we can see some few gates are there, these we will study, and we can program and design to decide for which input we want to make it on or off. Right? It's more like on and off system, switching. That's why the subject name is also switching theory. And what logic we are applying, switching theory and logic design. Second is information is very easy to store. So information storage is easy. That is the second advantage we can say. Third advantage we can say the accuracy is very high compared to the analog system. As we have seen the example of watch, analog watch and digital watch. The accuracy is very high, and precision is also greater. So precision and accuracy are high. Then another advantage we can say that digital systems are versatile. They are versatile, means we can have a variety of programs to run these analog digital systems. We can also embed them along with the analog systems and we can use them. And next one is they are less affected by noise. So noise is something which is unwanted signal. So this unwanted signal is less in digital systems. Then again another most important parameter which makes possibility of memory cards, microprocessors, controls, or what we call IC, is that more digital circuits can be fabricated on ICs. So this fabrication is easy on this. So we can add that point also as our advantages. Second one we can, in our list we can add that they are more reliable than analog system. So reliability is more. Fine. So these are more advantages. Now what could be the disadvantage? The disadvantage, if you want to list, there are no as such disadvantages much, but the major drawback is that it's not natural signal, right? And the real world, what we say, the real world or natural signal is analog. All the signals like voice signal and what I'm talking is an analog signal basically. Then this mic what we have connected, you can see on your screen, this one, these filters and mic assembly. I can show you there. So these will take my voice, analog voice, and they will convert it into digital. Then it will be processed in softwares and the video signals and all. So that is digital. But natural signals are analog. The real world is analog only. So this is about the analog systems. Now let us discuss about the logic levels. Next topic we can discuss is say logic levels. What is the logic and what are the logic levels? Now the reason why we can store more information on digital and in less space, and we require more space in analog. For that we'll take this example. We'll take two graphs. Say this is some analog graph. Signal is changing with respect to time. And for digital, the graph will have only two values. One will be plus and another one will be minus. So we'll have only plus, minus, plus, minus, plus, minus, like these signals we will have. So if we want to store this analog signal, what we have to store, say t equal to 1 second, for example. That value, this point we have to store. Say t equal to 2, this point we have to store. T equal to 3, this point. Then next point. Then next point. Like that, we have to keep storing all the values. To retrieve them again, you have to store these values. But in digital system, we have to remember only two values. Zeros and ones or zeros and ones. So in this language, we have only two values, resembling values, zeros and ones. So that only we have to remember. So that thing we have to remember, so it makes it easy. So here we can simply consider these signals, right? But our signal may be in the form of voltage. Say voltage may have some value. For example, suppose we will consider 5 volt is the voltage. Then how exactly we will decide it? Because we may not get exact 5 volt or exact 0 volt. We may get some intermediate value between 0 volt and say 5 volt. Then what if I get some value around 3.5 volt? Should I consider it on, or should I consider it off, or should I consider it 1, or should I consider it 0? 0 and 1 we can call in different way. Suppose 0 is there. 0 represents say no, or off, or non-conducting. That means it's a low signal, right? 1 we consider as high signal. That means it is a yes signal. That means it is a on signal. That means the device is conducting. These are all different meanings are there for these two signals. So 0 is low signal, 5 is high signal. Now if we explore this signal, here we can see one clock pulse. For example, say this is a switch. When we click on the switch, then what happens? That switch will make this circuit on, right? So here say it's a clock pulse. This range is high range, okay, and this one is low range. This positive going transition, that means what? This is going say upward. It is leading edge, what we call it as say leading edge, right? Second one is say negative going transition. First it went up, it stayed on the peak, then again it is coming down. Now this one is also called as trailing edge. So one is leading edge, another one is trailing edge. Now this is a simple switch we can represent. We have one plus positive supply voltage,